Greetings and welcome, friends. We're taking a look at page 507, Su Tarea de Anoche. We're talking about roots and zeros. And here is problem 27. It says, given a function and one of its zeros, find all the zeros of the function. So I'm going to set up my little chart here thing here. And I'm going to crank through this. This is going to be nice. So let's do this. So here we've got 1, -4, 6, -4. Okay, all right. And I know that 2 goes into it, so I'm going to start with 2z. And let's see, bring down the 1. 1 times 2 is 2, with a -4 is -2. 2 times -2 is -4, with a 6 is +2. 2 times 2 is 4, with a -4 is 0. So that verifies 2 is a 0. So now I want to actually work with the depressed polynomial, right? This 1, -2, 2. So I could actually do some guessing and checking if I wanted. Or perhaps better yet, I just might realize that because there's only 3 terms in it, it must be a quadratic, and I could perhaps solve by factoring, completing the square quadratic formula, blah, blah, blah. So let's try some other numbers here. Actually, oh, you know what? How many answers do I expect to have? 3. Has to be 3. Okay. You know what's funny? You could try forever on this, and you'd never find any real numbers that work. Yep. So, but there are 3 answers. It turns out there's a complex one. And if there's one answer that's imaginary, then there's 2 answers that are imaginary. So here I would have old g of x equals, what's this mean? X squared minus 2x minus 2. And if I want to solve that, I'm going to set that equal to 0 plus 2. Thank you. Good save, friend. Got my back. Oh, yeah. Here we go. X squared minus 2x plus 2. Set that equal to 0 and solve. I'm guessing that's not factorable since I just told you that there's not going to be any real answers. But I could solve by the quadratic formula or completing the square. I'm going to complete the square. This looks like a nicely completable square problem. Wow, man, you guys on top of your game today. Classic. So here we got x squared minus 2x blank equals -2 blank. I must have been thinking about this guy maybe, what my new c term is going to be. Remember, the new c is going to equal b divided by 2 all squared. That's going to be -1 squared, which is positive 1. So add 1 here, add 1 there. I can fast factor the left-hand side. We're all masters at this now, so I'm not going to take too long. Go watch some of the other videos if you need more practice on completing the square. It'd be a great idea. -2 plus 1 is -1. And now when I go to root both sides, you can see what the problem is here. Well, here's your problem. You're trying to work with real numbers. This thing's imaginary. Right? That's the same as plus or minus I. And then I could add 1 and 1 to both sides. Here we go. Bado. X equals 1 plus or minus I. Notice that is how many answers? 2. 2 answers there. 1 plus I and 1 minus I. So the original problem has 3 zeros. 1 plus I, 1 minus I, and positive 2 are the zeros. Okay? So yeah, that definitely would have been helpful to, once you realized you had a quadratic, don't try doing the guess and check thing. Although, next section, I think it is, we'll be talking about some ways of narrowing stuff like that down. Technically, once it was a quadratic, you guys could have even used the discriminant to figure out what kinds of answers we'd have. I don't know of, anyway, a discriminant for cubics to tell you what kind of answers you have. Although we might have a possibility of narrowing some down today, which will be interesting. Problem 29. This is a little bit trickier. It says h of x equals 4x to the 4th plus 17x squared plus 4. And it says 2i is one of my zeros. Now, I can't make a little chart and plug in 2i and synthetically divide by 2i. I don't know what that means. So let's see what happens here. It turns out step 1 is going to be find your depressed polynomial that has that as one of its roots. All right. So if this is one of the roots, then the factor must have been x with a what? Minus 2i, right? If positive 2i is a root, then x minus 2i is a factor. And tell you what, if 2i is a root, then what else do I know?
Negative 2i is a root.
Negative 2i is a root, right? If we have an imaginary friend, we also have an imaginary enemy. Imagination. So that means if if negative 2i is a 0 or a root, then what must my factor have been? X minus a negative 2i or plus 2i is even better. So here's a depressed polynomial that contains those two roots. How many roots do I expect this problem to have, by the way? 4. It's got to have 4, guaranteed. The other 2 might be real, other 2 might be imaginary. We'll have to wait and see, friend. We'll wait and see. So let's multiply this out and see what we get. So x times x is x squared plus, oh, my favorite, Twix. And then minus 2i times x is minus Twix. Oh, man, someone ate my Twix. And then negative 2i times positive 2i is going to be minus 4i squared. You might realize Twix and Twix cancel each other out. Equals x squared. What's this simplify to be?
4.
Plus 4. That's correct. So this is a depressed polynomial, but I'm not interested in setting it equal to 0 and solving it because I already know what its answers would be. I want to find the other 2 that I'm looking for. So what I'm going to do is divide by this depressed polynomial, giving me another depressed polynomial that will contain the missing 2 answers. And actually, question, if my other depressed polynomial is going to have the missing 2 roots, what must its degree be? 2. It's got to be, right? If it's containing 2 roots, it's got to have a degree of 2. That's kind of using our concept in reverse. So step 1 for this, I laid it out in the notes, was find your complex conjugate, find your depressed polynomial that would have those as its roots, and now step 2 is long divide by your depressed polynomial. So I'm going to have x squared plus 0x plus 4. That's right. That's my divisor. And I'm dividing that into 4x to the 4th plus 0x cubed plus 17x squared. Oh, plus 0x plus 4. Wow. Always looks like it says ox. Or ox cubed. So, Oxford. So let's long divide this. Divide the leading term by the leading term. 4x to the 4th divided by x squared is going to be 4x squared. So once again, I'm expecting this might have 2 other terms here. Notice it already is indicating that it's going to be having 2 roots. The 2 roots I'm looking for. 4x squared times x squared is 4x to the 4th. 4x squared times 0x. 0x cubed. 4x squared times 4 is going to be plus 16x squared. Bless you. Subtract step. 0, 0, 17 minus 16. 1x squared. And then I think I'm going to actually end up having to double bring down here in a second. Well, you'll see what happens. It's related to the fact that this is a trinomial. But let's assume I didn't and see what happens. We'll realize that we'll need it in a moment. So let's see, divide leading term by leading term. What is x squared divided by x squared? 1. Which column should that go in?
That one. Oh,
The constants column. So we'll multiply this by all of those, right? Bam. So 1 times x squared. 1 times ox is 1 ox. Oh, no. Just 0 ox. I'm sorry, I lied. And 1 times 4 is 4. And then when you notice on the subtract step, it's like, oh, wait a minute. I kind of need this guy here, don't I? So that's why I'd realize I need to double the brought down. And subtract, oh, what do you know? The remainder is going to be 0, just like we needed it to. Otherwise, this would have not truly been a depressed polynomial of this guy. If its remainder wasn't 0, that wouldn't have worked out. So, what is my other depressed polynomial here? Yeah, 4x squared plus 1, I'll call it q of x in this case, is equal to 4x squared plus 1. Well, normally I'd call it h of x, but the original problem they didn't call f of x, so they've thrown me all off. And also I thought q because it's the quotient. I don't know. Thought it was a good idea maybe. So 4x squared plus 1, step 3 of this process, if I'm looking for the other roots of this original polynomial, I'm going to set that equal to 0 and solve. Now question, do you think these roots are going to be real or imaginary? Is it possible to have one? Could one of them be imaginary? No, it's either all or nothing. It's imaginary roots come in pairs, all right? They always have a twin. So if one of them is imaginary, both of them are imaginary. Watch this little trick for solving. By the way, there's no sum of two squares pattern, even though this is a perfect square and this is a perfect square. But there's no middle term, so instead of trying to factor or do it any other way, watch this old trickaroo. I'm not even going to have to do any real fancy stuff. I could divide both sides by 4 here, I suppose. Since I only had one variable represented, I can just isolate that variable. -1/4. And what do you think I do here to get x by itself? Root. Plus or minus, don't forget it. It's imaginary. You mean they are imaginary. Plus or minus square root of -1 is I. And actually, I might write the other part in here. Square root of 4 is 2, but it's in the denominator, so this is going to be like plus or minus a half an I. Ugh. Half an eyeball would be gross. So there are my other 2 roots. So this problem had how many roots? 4. Well, the original problem, I realized the vagueness of my pronoun there. When I said, is this a pronoun? I imagine it is, right? That probably makes sense. So yeah, this original problem had 4 roots. And how many did I find? I found 4 altogether. How wonderful is that? So if I wanted to list them all, I could have actually just, for the original problem, it would have been plus or minus 2i and plus or minus half an I. Those would be all of the roots for the whole problem. They were just looking for the extras, which I guess I did find the -2, or was it -2i? Yeah, it was the other one I found. So there's all those all the MDL zeros. So thanks for watching, friends. Have a great day. Bye bye. I'll beep at you.